So let's talk about the analysis of variance. We are going to be comparing 3 or more means at one time. Now, we've never done that before. In chapter 11, we compared, chapter 10, we did 1 mean. Chapter 11, we did 2 means. Chapter 12, we did multiple proportions, but not means. Proportions because we were working with categorical data. So this is going to be analyzing the means for multiple things. So 3 means, 4 means, 5 means, and so on. It's an inferential method used to test the equality of 3 or more population means. The null hypothesis is going to be that all the means are equal, and the alternative is that at least one of them, maybe more, is different than the others. So I'm not going to read this question to you. I will just keep talking about it. So it's in the notes, so read it over. Basically, the airline didn't answer the phone and play different music or music or classical music or advertisements, and saw how long people would listen and wait, keeping in mind that they never ever were going to get to talk to anybody. All right, so here we go. They've got these different numbers. These were the holding times. These were the lengths of time that people were willing to wait and never get picked up on. So for advertisements, one person was willing to wait 5 minutes. One person was willing to wait 1 minute. One person was willing to wait 11 minutes, and so on. So the hypotheses for the ANOVA test is that the means for all 3 groups are the same. So let me bring that up here. Oops, there we go. Okay, so that the mean for the advertisements is equal to the mean for the music group. Music is that funky elevator music, right? And then classical. Oopsie. That they're all the same. That it doesn't matter what you play for these people, they're all going to be the same. Oops, let me do one thing right here. Okay. There we go. That's the null hypothesis. Okay. What about the alternative? Because it asks for both. The alternative is that at least one of those population means is different than the others. That's pretty much always that way for ANOVA. Okay. Next, the mean for the 3 groups are quite different, but that is not sufficient evidence to conclude the population means differ. Why? Okay, so you can see people had a much longer wait time with classical music than they did with music than they did with advertisements. But just because we see difference there is not enough to say that they're different. Why? Well, because we don't expect them to be identical to each other. The question is, are the differences we're seeing between the 3 groups large enough to be statistically significant? i.e., we need a formal test for this. Okay. So, next, they have us looking here, I think, at these dot plots. And it says the top figure shows the same data as in our table with dot plots, right? So somebody here, music, somebody was only willing to listen for 0 minutes, 1 minute, 3 minutes, and so on, 4 minutes. See it? Okay. So the bottom figure shows the data that have the same means but different standard deviations, which gives us stronger evidence against the null hypothesis. Okay, just look at this. If you're trying to argue that these are the same, the top graph is kind of muddy. Like, you can't really get out what's going on. But if you look at the bottom graph, you can see, look at these classicals. These are the classical dots. These are the advertisement dots, and these are music dots. You can see that classical is significantly different than the rest because the clump of classical dots are way far away from the rest of the group. Matter of fact, that's what I'm going to argue. Okay, there it is. So in the second picture, you can see the classical data is far removed from the rest of the groups, which shows stronger evidence against the null hypothesis. In other words, in the top picture, everybody's got more variability, so they're all overlapping, so that doesn't show you much. But in the bottom picture, much smaller variability, so they don't overlap. So they're much tighter packed.